Hello everybody, I'm here today to show you how to draw a shear in a moment diagram. As you see here, we have the problem and we broke it down into the reaction forces and the resultant force and etc. And this is the result right here. And I'm going to show you how to draw that shear in moment diagram. Keep in mind this is a basic problem, but will give you the idea. The first thing you need to do is whenever you have a problem is you have to study the connections. In this case, I have a pen connection, roller connection, and then a pen connection. Based on these connections, you would automatically, from your statics book, you will know that there are certain reactions based on the connections. In this case, our reaction doesn't deals with, for the pin connection, something like that, and for the roller. Before you solve any problems, you should always have a reference point axis. In this case, in my case, I'm going to say that anything in the right direction is going to be positive, and anything in this direction, in the upright position, it's going to be positive. So that's my reference axial. Having said that, you start solving for the resultant force and the reaction forces, or most importantly, draw your free body diagram. So our free body diagram here will consist of, this is the bar, and let's call this RA, and I'm going to call this one RAX, this one RB. Now we all know that the resultant force will always be in the center. In this case, since we're dealing with a rectangular, our resultant force will be in the middle. And in our case, this resultant force, the distance is 2 millimeters, and it's 12. And in case you forgot how to solve for the resultant force, it's basically the area of that distributed force. In our case, FR equals 3 times the length, and you get 12 kilonewtons. Okay? So now, the next point is you need to solve for the reaction forces. First thing I would do is the sum of all forces in the X equals 0, since this is a static equilibrium. In our case, all we have is RAX, and we don't have any other force acting in the X direction, so we automatically know that RAX equals 0. Now you do the summation in the forces in the Y direction, and you can also always put a reference here saying anything in the right is positive, anything in the up directions is positive. So all the forces acting up in the Y forces. So in our case we have RA, and our resultant force will be a negative since it's going down, and our other force is RB equals 0. Now you'll notice that in this equation we have one equation, two unknowns. So that means you have to come up with another equation to solve those unknown variables. And the other equation I can think of is the summation of the moment. And then in my point, what I'm going to do is I'm going to say this is going to be my reference point, point A. And I'm going to say that anything that makes the bar, any force that is applied on the bar that goes clockwise, I'm going to say that that's positive, and anything that's taking it counterclockwise, I'm going to say negative. Okay, so my reference here, I will say the moment at point A, as a reminder, anything clockwise is positive, equals 0. in case you forgot, our free body diagram, we have a force here, 12. We have RB, and we have RA, and the distance here is 2, and the total distance is 4. Okay, so the moment would be, in this case we have the resultant force, which is 12, and the moment is, in case you forgot, it's force times distance, or the perpendicular distance. In our case, as you see right here, is 12 times the distance, which is 2, and it's going to be positive because if this force was applied and we had just only that pin connection at point A right here, this automatically will take the bar clockwise, so we say it's positive. Now RB, in this case, that force, if it's applied, it will make the bar turn counterclockwise, so it will be minus RB times the distance, which equals 4, equals 0. So now we solve for RB. In our case, RB would be 6 kilonewtons. So now you already solved for the reaction force at point B. Now you go back into this equation and solve for RA. Once you plug everything in, you'll get RA equals 6 kilonewtons.